morning. Going to reply to a couple comments under sparklers in a vacuum, or at least one. Let's see. I did not know they use sparklers in rocket engines. Let's try this experiment with liquid hydrogen and oxygen. Alternatively, you can try thermite and see if it burns in a vacuum. Also, this experiment of yours means that you cannot weld underwater, which I replied, welding is done underwater and in a vacuum, obviously. So I was looking at another one, but another video showing, of course. I might leave the link, or I might just do another video on it. But rocket engines in a vacuum, and the guy's deceivious. I'm looking at it now on the TV, and it says 0.02 atmospheres. Okay, if you want to, whatever. Got to use a terminology for others to understand that. Still quite dead in the head, but watching it, and it ignites, but he's got 0.02 atmospheres, which is not even close. It's close. Anyway, I might do a complete other video on that. But anyway, answering thermite, and I told him, let's see. I'll try and find it. It was okay. Outside the chamber would ignite and burn immediately. In the chamber, at most, smoke. And I'll try to find it. Someone had a video go back. Yeah. Okay. Well, I found the video. Cody's lab. I'm just going to play this one real quick clip here. Where is it? Okay, here we go.
About it, and everything I've tried up to this point has produced gases as a product of its combustion. So I thought, what if I tried something that didn't produce gases? How about some thermite? This is a mixture of iron oxide and aluminum. Well, normally this is actually magnesium powder because I didn't have any aluminum on hand. But the idea here is that the reaction will not produce gases. Might make a little bit, but primarily the product of the reaction is going to be molten iron. And molten iron, of course, it's not a gas, so it's not going to leave as quickly, so maybe it can help chain the reaction along. So, let's test this out. This is a thermite reaction in Earth's atmosphere. Here we go. That burned up. I can see that there's little bits of iron, some magnesium oxide floating around. A little bit of smoke, but again, that's probably just from contaminants that burned up. So there we go. Let's try it in the vacuum. I did not get an ignition. I see pieces flying all over the place, but none are actually igniting. I'm going to try again with the thermite, but this time I'm going to bake out any volatiles from the iron oxide first. That way, perhaps the laser won't push the pile around quite so much. Okay, I'd say that's fairly well cooked. Let's try it out in a thermite mixture. This time it's been baked. It's inside of a vacuum. Let's see if we can get it to light. There's sparks. Oh, it's burning. It is actually burning. Oh, that is cool. It actually burned. It burned very slowly, but it actually worked. Oh, that was cool. So I was able to get a fire in there. It just, it didn't really look like a fire at first glance, but it was burning. So there you have it. It is very difficult, but possible to get something to burn in a vacuum. Although, I'm using it as a rocket engine for some reason.
That's it. So yeah, will that produce a? Didn't show. I don't think he showed what the vacuum was, and was it 30 inches, 29.9, whatever. Don't know, but would that produce thrust? Not for long. It would be out in a second, a split second. So. Yeah, take it for what you want. Compare in the air and in a vacuum. There you go. But I might do another video on this other guy, Deceiver, because he admits that it's not in a vacuum twice. But anyway, that's it. Later.